Narayana that was on the Fast AI forums, and he mentioned something about AI Saturdays.
There's somebody doing a Saturdays in Bay Area or something like that. Right? Yeah, we were talking about, I mean, there are, like, even in the Fast AI forum, they are having some study groups and join them. Or how do we move forward? I mean, you want to, or I can sit here. I'm trying to move closer to the things. Yeah. So. Then, I mean, David had mentioned that there were some people in that other the meetup where he made a presentation that they were interested. Mm-hmm. So, in rebooting like Fast AI Deep Learning 1 thing, so we thought, okay, I mean, is anybody interested in stuff? I mean, if they are interested, they should show up today to discuss something if they are interested. So I don't know.
Well, there wasn't a lot of time between your post and.
I know, so, but at least acknowledge or something, saying, hey, I'm interested. I mean, Keith and other people had said they would like to do something, and
that will get Keith. I've been trying to get him to come here for a while.
Oh, okay.
He's always busy.
Okay. Okay. And then he came one day, and then he hasn't come after that. What's his name? The other guy. Yeah.
I think
he had a beard and stuff.
We're like the core group.
Yeah, only the core group was interested in this stuff. Is your wife okay now? I think last week we couldn't make it.
She can walk.
Okay.
Up in the boot without crutches at least now. So.
Okay. I mean, just broke her ankle just like that, not playing sports or anything, or
trampoline park. But it was a trampoline park. But
trampoline park.
Rolled it when landing.
Okay.
Can happen. Can happen without a trampoline too. But it's minor. Still not very convenient.
Oh yeah.
She can drive for like a month.
Because you can't even put
right
leg.
Okay.
Unless you just like drive with the left foot.
You can.
Yeah.
I learned to do that because I injured my leg.
Yeah.
You can cross your leg. It's a little bit dangerous in the beginning. But you get used to it. I actually got really good at it. I became ambidextrous. But in the beginning, when you brake, you gotta be very careful. But I didn't have a choice because I had a nerve problem in my right leg, so I couldn't use it. So I had to train myself to drive like this.
I would do it, but I'm definitely not going to advise her to do it.
Yeah,
you may need to be very careful.
Yeah, like I was
because
my other leg, like or something.
You gotta. There's a special way to sit. And you just gotta but it's kind of risky. I did it for like a year and a half.
I should have
Just waiting for the self-driving.
car is
She doesn't go much on the highway, which is where it actually works. So not useful for her. For me, it would be.
Yes, Elon to work hard. You guys see the meeting we did?
I didn't watch it yet.
I know. He is so stressed or something.
120 hours a week.
That's what I haven't actually heard anything besides that. It might not be true.
What?
They said
he choked on multiple times during the interview.
He's at 80.
Slept like a baby. Curled up in a fetal position. Yeah. No, I feel a little bad for him, but I think he also like chose
Yeah.
like to do all of this, like, you know, to put job before family, do all that stuff, and then like it's hard to feel sympathy for a multi-billionaire. He was like I mean, it's true. He's a workaholic, and this is like, yeah. But at the same time, it's like there is a human aspect to like seeing something that you love starting to like fail and like feeling like your whole life is unraveling or whatever. I
And
imagine
it was on the
right?
verge of failure from both the companies.
Yeah. For a while, a few years ago, there were both companies were having trouble. Now SpaceX is doing quite well, but Tesla is still. Yeah.
He's got solar seed too.
Hmm?
He's got solar seed.
It's merged with Tesla.
Oh,
That's
right.
right. No, Tesla is doing really well. It's just the 30% of stock is short. And
Because they're losing money on every car.
short. They're not losing money on any car.
No.
They're reinvesting it.
Yeah. But
you're,
I mean,
you're reading Seeking Alpha, aren't you?
I mean, it's
That's
the
all
thing
short
is, I mean,
term. That's where all the short
everybody
term.
understands that you lose money when you start. I mean, when does he? You
can't-
got to
yeah,
tell
but
them
you
where you break even and stuff.
You can't say that you lose money. Like that's a totally wrong thing to say.
Yeah.
It's like I bought.
No, he
I bought
just
$1
needs to get
million
funded. He
I
just
bought
needs
$1 million machine.
Yeah.
And I'm selling $1 things out of them, but I can sell.
Million
a
Well,
lot, right?
this is the same
Yeah,
argument
but-
that they made against Facebook and Amazon
No,
for
no,
years and
no,
years
no,
and
no.
years.
Years, yeah.
Oh, they
It's
still
just-
haven't reaped a profit. Oh, well, they're really big, but they're not reaping a profit.
Profit, yeah.
And now it's like Amazon like owns the world.
They just
and
need,
they're
they just flip a switch, stop new development. Here's the money pouring in. Or not stop, but
No,
still-
it is not. I mean, it's just that can they keep getting the, I mean, Amazon used to get the funds all the time. I mean, they were able to raise funds because every time they used to show revenue growth every quarter. I mean, if you can show revenue growth, nobody cares ultimately. I mean, if you're able to sell more cars and more cars every quarter, then those profitability things will not appear as much as a question. Okay, you just have to keep selling because Amazon was able to because they can keep tapping the funding. Here, we don't know how long he can tap funding. If there is any slowdown in his name, because they're trying not to sell the 35K, they want to sell the 50K and above.
That's what they have to do to until they can ramp up
And stuff. But they will have a lot of, I mean, when you go through that, you'll have a lot of pressure because it'll be everybody will short you.
And that's why he wants to go private. To
But who's
alleviate all of that.
Yeah, but who's going to give him the money and all that? And
The Saudis.
Yeah.
And that's
the
needed.
Chinese, okay, next is the
No,
Chinese.
that's gonna be needed only for like 30% or less. Because the rest of the investors are gonna stay as private investors. It's not gonna be owned by Saudis.
No, it's not going to be owned.
30% maybe.
Maybe.
What are you gonna do with AI?
Okay, one thing I thought of sharing.
We're actually gonna go over something first.
No, a notebook. I just thought I was talking to David yesterday about this. Check if this was the one. Yeah, so I wasn't getting anywhere with, I mean, I was trying a lot of stuff on this Kaggle competition. I mean, beyond 70.75, I wasn't getting much above that 0.75. I was doing a few things here and there, and then so then what I did was, I mean, I was starting to look at these the images visually, and I said, I just so these train images, I was doing the train images, and I started looking at these images, and I said there are some images which are just black in these training images. Why even go and send that to the model? I mean, there's no point. I mean, if it's a black, I know the mask is going to be black. So there was no reason to send that thing. So then I also saw there were like almost whitish stuff. Like there are some images that are almost, in these things black, okay, you see a lot of blacks, but out of 4,000, there are only 80 images like that, which are black. So I thought I could just take it away from the training itself. And then if anything is black in the test image, I'll say the mask is going to be black. Why even have the model do something on it? So I was trying that. I mean, that didn't do any, I mean, hardly any improvement in the score because of that, because I saw that the model had actually learned to identify the black as, you know, I mean, it was able to learn it pretty. There was not a single image it actually predicted wrong in these black things. So then I was going with the white and stuff. So what did I do here? I was just playing around with so that's where, if you look at this was on the test, isn't it? This was on the test image, test DF. So even I was looking at even in the test images, I mean, out of 20,000, about 400 or 450 are black images. If you see, I was just plotting like I call the gray coverage. I was just summing up the pixels in the image. I was just plotting that, okay, they have some black images, and then they have, but other than that, I mean, this is pretty much spread. The pixel, the average pixels in the images are pretty good spread around, other than this thing here. So I was trying that, and then that wasn't getting me anywhere because I was throwing out anything with like grayscale, but the gray, the pixel sum either equal to 0.0, less than say 0.05 or something like that. I was throwing it out, and then I said anything greater than 0.99 or something like that. I was throwing that. Those are kind of not even worth analyzing, and I'll do the mask. I'll just predict the mask as zero mask for that. So that wasn't getting anywhere. So then what I did was I was just playing around with it, and I was looking at the height and then saying, is the height making any difference? Remember, I was trying to regress on the height, and then the height, you can, I mean, that hardly R squared of less than 0.2 or something like that on the regression I was doing from the images to the depth, the height, depth. So that one I couldn't find anything. So where I landed was I was doing some calculations and stuff on the depth. The one thing I saw on the depth was I said, how does the pixels distributed on the images with less than the mean depth and with the greater than the mean depth. So when I plotted this, when you see the dark green, it's covering both the blue and the green. When you see the light green, that's that one is where it's greater than the mean depth is about 510. The mean depth in the images is about 510. So I was doing that, and I saw a slide. I mean, there is some variation in the distribution of the pixels, where in the less than 510 depth versus the greater than 510 depth. So I said, it's
it doesn't look significant.
It looks significant to you, yeah, but there is some slight difference though. I mean, this is coming up like this, and this is going up like this. there's some amount of increase here, some amount of increase here on the pixels here, where this is,
couldn't that just be within the distribution of randomness that?
Could be. Yeah, I haven't done a statistical analysis. All I saw was, okay, these are all pretty close together and these pixel sizes. But once you get to 0.2 and 0.3 average pixels, I'm seeing this has a little bit higher stuff on this. And then this blue is more higher here because the green is lower here. So I just went on a hunch saying that, okay, there's some differences between less than the mean depth and the greater than the mean depth.
Sorry, Divya says she can only see your face.
Oh, sorry. Yeah. Yeah, I didn't share my screen. The screen share. Yeah, I mean, yeah, I agree with you. I just thought, okay, yeah, this is not significant, but there is some difference here. So I just then did, as I was telling David yesterday, I went and what I did was train the model with less than, I took the training images and I said, give me less than, I'll show you here where the split images is where it's going to be somewhere here, isn't it? Not this DF. Yeah. So I said, give me the training data, which where the Z, the depth is less than 510. Okay. And so I said, let me just use that data. And I split it 20%, 0.8, 80%, 20% on it. So when I did that, and then when I did that and then trained it again, I was able to push my accuracy to 0.80 or 0.80, sometimes 0.80. What was the best I got? From 0.75. Okay. I mean, it's just, I thought is 0.8012. Yeah, I've gotten until 0.803 or something like that. While I was not struggling, I was struggling. If I put all the images, I couldn't get anything above 0.75. So I did that. And then when I trained the other one with the greater than 500, I don't have that copy here. When I trained it greater than 500, I was able to train that to something like 0.735, 0.74 kind of thing. So I have not submitted a mixture. So I'm thinking, okay, I have two models now, one for greater than the less than the depth and the less than the mean, and one is greater than the mean. And then try to do separate models because the test images also have the depths given for that, and try to see if I can get a better score than 0.75. So I still have to try that.
But you got lower score on the...
Not that much lower. I got from 0.75 to say 0.74. Not that much lower.
That much, but still lower.
But I could go from 0.75 to 0.8 on the other one, less than the mean. So I'm saying, yeah, I was able to bump it up.
On average, yes.
On average, I should do better. Because those things were split. Because I'm splitting on the mean, they were pretty much split equal. Like I got 2,000 images on this side and 2,000 images on this side. They've given a even distribution of the depth.
What happens if you run the original model?
Yeah.
With the test set that's only below or above the mean?
I have to do that and say, oh, but I will never know the answer because I can't run the test set with the lower because I have to submit the whole thing.
Sorry, but
oh,
do the predictions on the original.
The prediction on the
training set, sorry.
Okay, prediction on the training set to see whether, I mean, yeah, you're raising a good point there, whether the accuracy will be any better at all.
How much?
See, when I was plotting this, when I was plotting the, like, what was it getting wrong and what was it getting right? I mean, you'll see that on the validation images, which was 20% of the 2,000, which is about 20,400 images. It was getting most of it correct, but here's where it was getting 50 images, 0 score. I'm getting 0 score. It's not completely wrong. because it's very difficult when I looked at it, I was also telling David this, when I was looking at it, where am I getting it completely wrong? Is like when the coverage is, this is what is the, I think, which side is it? The left is the prediction, and then the actual mask is the right number. So I'm using the coverage, the mask coverage there. It's predicting wrong in these things where the mask coverage is very small, okay? That's when you get, when you're not, because they're giving you a score for every image. Like if you can't get a IOU metric greater than 0.5, you get nothing, no score for that image. It's like when you get into these very small images, where the mask is very small, like if the mask is only like this, and unless you pretty much have to predict at least this much, at least half the coverage at the right place. Otherwise, you'll get 0. Because in a bigger thing, yeah, if the mask is like this, and even if you get something like this and stuff, I mean, you'll get, or like it's easier to get a score with a bigger mask. But when the mask is small, you got to be very, I mean, they got to be right at the, I mean, your prediction mask could have gone like this and stuff, and you would still get a good score. Because
where there's a little bit of salt is where you're having trouble.
You're having trouble.
Yeah.
That's and you get 0.
Yeah, I had the same problem with my drone thing.
Oh,
with the monk crosses. I mean, when there's a lot of it,
yeah,
it's easy even for a human to say, okay, that's a monk crowd. But when it's like a small scattering on the side,
yeah,
then it's really hard to
use the green.
Yeah, the green means green is the mask, and when it's covering the light brown is what my prediction is. When it's dark brown, that means the green and the thing it's covering that, because I wanted to put it on the same thing. So this means like here, it's getting it, the green is a little bit more than that. See, the coverage is 0.061, and then my predicted coverage was about 0.049. I'm just averaging the mean coverage there, but it still has to get it in the right. I mean, this one I got it. I mean, here I didn't get a mark for that. Here, this is 0.047, and my coverage is 0.026 here at the bottom. I mean, here is where the mask is, and you got to get it pretty close, correct, to get a score on that.
You didn't get a score.
I didn't get a score on that because I was just plotting the ones where I didn't get a score. Where I'm getting 0 scores. Okay, here is 0.012. I mean, there is a slight mask there. I'm not predicting any mask. Then if you don't predict mask, you get a 0 score on that image. Like 0.013, there is a slight mask here. And you're gonna,
probably are not even possible to predict with a model.
Yeah, I don't know. Because a lot of those things, I mean,
probably impossible.
Yeah,
probably impossible to predict anyway. So it's what to focus on are the bigger ones. Like
that's why I have to see is, okay, this is now going, and it's not gone into this lip here. It only went and predicted a little bit here. It hasn't gone and predicted the full loop here. So those are the things I can I can try to see. I mean, it's very difficult. I don't know why it's not getting that correct. But remember, it's getting most of it is correct. Otherwise, you won't get a 0.8 validation thing. I mean, it's getting a ton of it correct.
What are people getting on Kaggle?
Oh, sorry.
Kaggle, I mean, the score they're getting, but because I'm only getting this on the less than thing, I'm getting 0.805. Okay, and then I can apply the CRF that they talk about in the Kaggle competition, maybe push it up another 0.1 or where what the CRF does is, instead of, because these are very rugged, what it does is it smoothens the mask. And it seems when you smoothen the mask, you do get a bump in score, a little bit bump in score. Not a huge bump in score, you'll get a 0.1 bump in score.
How is the salt distributed in the panels? Like
averaged. Is that what
Did you try growing?
Huh?
Did you try growing it by a pixel in every direction? Growing the mask?
Okay, growing the mask.
Yeah, by So
distributed,
basically
but the
mark
edges are, like,
each
scattered.
pixel next to
And
the
it's hard
pixel
for
that's
the
already marked.
algorithm to figure out
Yeah.
Mark it also
whether
black.
there's a lot of
Okay.
outliers and-
I mean, yeah, it's
That's
worth
cool work.
trying. Yeah,
Might not.
those are. I mean, because that's what people in the Kaggle discussion are saying. If somebody they're doing some pre-processing and post-processing of the data to get because the highest score is 0.85. Okay, but that's the total. I mean, for me, I was not able to train it just like whatever I was using, different learning rates and schedule the cosine annealing stuff. I was able to get 0.755 or something like that. And I can probably be using the CRF, I can improve it to 0.65 because the 0.1, everybody sees there is a CRF. If you apply, you get a 0.1 bump just to smoothen it. So, I mean, yeah.
0.01.
Huh? 0.01, sorry, 0.0, not 0.1, 0.01. Yeah. Yeah, but it is getting some of these very, very wrong. So I don't know why. I mean, this is all green and it's just getting only 0.007 of that. So
I don't know if I believe these masks.
Yeah, I suspect some of these are mislabeled.
Yeah, I don't know. Like, this looks weird to me. I've never seen anything where
Yeah.
Mask like this?
illustrations are going this way. There's this weird vertical.
That's wrong.
Yeah.
And then over here, like this is like going over the tops of humps and stuff.
yeah,
That's not what I was seeing when we were looking at them side by side. The mask and the they always.
But there are
no,
a
if you
lot of
look at,
them,
there are a
so
lot of
some of them
masks.
were-
So you haven't
might be
seen the,
just-
Yeah, so
I
when
mean,
you saw those and then on the same screen.
yes, the same screen, but I'm just saying the masks could be weird.
It looked like they might have been. Sorry. Can you go back to that overlay?
Oh, something else.
Overlay, oh, okay. Like there is a mask like 0.001. I mean, there's hardly any, I mean, there is a very tiny bit of mask there in the picture.
Yeah.
So-
Because like some of them, it looks like it's like, I believe that. I don't believe that.
You don't believe this kind of a mask that they would have done? Okay.
Yeah, definitely.
Don't believe this mask here,
Yeah.
which is almost a straight line. I mean, they must have done that. Let me go back here and
But
find a mask like that.
But when they do that,
I mean, this here is a white mask, which is but this side. It's not a,
Suspicious, though.
huh?
that looks.
This mask looks suspicious.
Just from like my understanding of genealogy, like letters don't.
I'm just trying to find a mask. I mean, here is a mask. Okay, there is a very slight bit of mask here. It's like, it's how much are you gonna?
Well, it doesn't mean that it's not useful.
Yeah. Oh, yeah. No, I'm trying to find a mask. See here, this is half the mask, like straight here.
And the one that's two to the right with that.
Yeah.
That looks like a mark.
See, there is a black, and then there is a white in the middle, and then there is a okay. No, these are above because remember these are radar. They are reflections, so they are not XY coordinates. They are XZ coordinates.
I suspect that they have really huge images.
Yeah, like you said. I mean, then they're cutting it off.
10,000
Yeah.
pixels by
Yeah.
10,000 pixels or something.
That's what I had. Yeah.
And then,
Yeah.
then they take and
About them.
break this up into a big grid.
Yeah.
And then what we're seeing is this little gridded thing.
Yeah.
That's what I did with my ortho photos too. I
Yeah.
cropped them.
Yeah.
And then at the end, they have a processing pipeline that breaks these up. They want to do machine learning and then it stitches them all back together because machine learning can't work on 10,000 by 10,000
In
photos.
photos, yeah. Yeah.
That's what I did.
And so then you end up with some that have like huge masks like this
Yeah.
that cover like the whole thing except for this little tiny corner. And
Yeah.
others that are totally masked and others
Yeah.
that are totally unmasked.
Unmatched, yeah.
And so that's consistent with what we're seeing here.
Yeah. Yeah.
But that doesn't mean that the things that are totally masked don't tell you something about what salt looks like, right? Because the statistics of the image
Yeah.
may actually be different than the statistics of the image down here, like just like its contrast and how things
Yeah.
move and stuff.
Yeah.
So just because it's within one single picture, it's all masked or all not masked, the machine learning model could still learn something from it.
Oh, yeah. I'm
So
not
I
saying
wouldn't-
it is not.
I thought you
done.
said you were throwing all those out. If
No,
it were
no,
all
no,
mask,
I
all
was-
not mask.
Which one?
Tried it, but didn't.
No, it didn't work. So I just
didn't
tried that.
Oh,
Because I
okay.
was just throwing, because all I said was, no, not on this, on the images is where I was throwing it. Not all the mask I was not throwing out. See, you got images which are completely empty, okay?
Not the
Not the mask. This is what I was throwing out.
Totally empty, yeah.
So because every
They
image I
just didn't get
checked,
a read.
every image here and the mask was completely empty too.
Oh, okay.
Okay, that's what I was throwing it out.
Okay, I totally agree. You can throw those
But
out.
out of a 4,000, it was only like 80, and it didn't make a difference because the model had already learned. These were the ones which were just perfectly predicting that. So just throwing it out didn't make any difference to me.
And then
I mean, it
think
may
what
have-
they're giving you for the depth is like the average depth.
The average
The
depth,
center
yeah,
of
the center of that, yes.
So
That's all
then
you're
you
getting.
know, oh yeah, this one was actually at this depth.
Yeah.
It's-
That's how you have to stitch the image. Otherwise, how you stitch the image if you don't know where it came from? I mean,
Well, I mean, they probably know even more,
yeah.
like.
Yeah.
Not only that, but also its lateral position.
But that's an interesting thing. What you're saying is, should we stitch these in? If along well, we don't know.
You don't know.
Which-
It could be that they took 10% and they give you 10%, right?
Probably don't.
Right.
Oh,
Random.
you can't connect the whole thing, yeah, because the
Yeah.
training images because they say the test images are 20,000, but that they said is only 33% of the images they've given you on the test set. And when the competition closes, when the leaderboard is, they're going to give the next 66%, where you got to submit your
And
model
then
again.
once you
and
stitch
take
them
that.
together, I'm not sure you would know anything more anyway.
Yeah,
Like, I don't know what, I thought about that too, and then I was like, okay, now I've stitched it together, now what?
So you,
I guess I don't know what else to do.
you could make the model more accurate by, like,
Because you know it's neighbors at that point.
by the neighbors, yeah. So if all of the surrounding ones you predicted are not so, and this one in the middle has completely gray, and the model can't really predict it.
Sure, yeah, that's true. If you were able to stitch all of the data in the validation
So you
set,
couldn't.
or the test set together, then you could get better
yeah.
accuracy potentially. Like in here, you could be like, oh yeah, this one's mostly black, this one's mostly black, this is probably mostly black.
I'm more concerned about just the suspicious looking map, like the one that was a bar.
Yeah, we
Can you
did.
track down the one that looked like a
The barcode. Yeah.
Oh,
Search for that.
yeah. Let me
No,
look
there
at that.
were-
I can look at the
there were
image.
ones
I mean, I
with-
just see, stop me when you see it.
So if they're saying, if this was
There you go.
masked,
Stop.
like,
Oh, this one?
Yeah.
This
there-
one,
there were-
yeah, I'll open another window.
there was one with like multiple lines that were
Yeah,
completely
it was like
straight.
there was like white and then black and then white, and then it was like all like perfectly vertical.
I can search for that
We need
image.
masks, right? Oh,
No,
you're-
I have the
you're
mask
looking for that.
here. I'm just looking at, what is it,
Okay.
2BC 179?
Yeah, it's like I can see why it thought that, but it still is like mislabeled in the sense that it's not.
Like no human would have
Yeah.
drawn a perfectly straight line on that, right?
No.
Here, yeah.
Yeah, like. I mean, do you think it's possible that when they were doing it to images this big, they were just kind of sloppy? So, and like when it's a big image that it looks okay, but when you actually go put it on little pieces, like there are just parts of it that are.
Instead of using
Well,
the lasso
you
in
would think
Photoshop,
that-
they were
Yeah,
using
they
this
were just-
straight
So
thing.
there's not even a single pixel difference between the bottom and the top, but for 100 pixels,
Yeah.
like.
Yeah, but they've drawn
It
a
could
line
be
like
the
this.
case, it could be the case if what they were doing over here wasn't drawing like, with a paint program where you paint the
Yeah,
pixels.
it was just.
But
like
instead you were
stuff.
doing
Oh, like, but yeah.
That's what I was
polygon,
saying, instead
right.
of the
And so
lasso,
then-
you're doing the vector.
yeah, if you're just doing polygons,
Yeah.
then it's possible that you have a polygon with an edge that is like straight up and down.
But there are some that are curved. like
Yeah,
like
some
90%
occur.
of the mass are there. Some are just-
So we don't know, that's one of the.
See, a lot of those
problems with
occur.
these Kaggle competitions is you don't actually know how the data is collected.
Like, do you think at the company they just gave it to like 10 different people? And, like, have at it?
They have experts. So
Yeah.
you
Yeah,
can
this one is the opposite of that.
discard
That one
completely
had,
straight lines. It would be a bit hard to detect it, but
no, you can't, you don't know that. This is the mask is they've given you that. You can't,
no, I understand.
Oh,
Discard
okay.
it from the training completely.
training
With any
completely, put that
completely straight lines.
straight lines and see if that makes a difference, yeah.
I mean, but even stuff like this, I don't necessarily trust because it's too vertical.
Yeah.
That looks
Just
okay
so-
though. That's not. It,
I
it
bet,
does.
like, it's
It does
really-
curve. It does curve.
Like
Yeah.
there should be far more horizontal stuff than vertical stuff. Depending on how zoomed into the different folds you are.
Well, the salt could appear like vertically.
Yeah, like depending, so like
Yeah.
overall, the layer is horizontal, but it goes like this, so if you're zoomed in far enough, it could be just on one of the like variant vertical bits.
Let me,
But I still, yeah, I agree, there looks to be far too many of those.
Yeah, there's their.
yeah, this one, this one.
For FDC.
Oh, 4
Oh, yeah,
FDC.
there's
Oh, this one is even more weird, yeah, because they have a mask in between the black thing and the black 4
I
FDC.
don't think. oh. I mean, I guess it could if somebody drilled a well and it filled up the salt.
Yeah, 4 FDC is this, and there is
Yeah.
no way this is gonna have a little bit of white mask here, and then a white mask starts here.
Yeah.
Well, that's kind of frustrating that you have, how many training samples do they give?
4,000.
I wonder if somehow like what they're testing it on, they kept like the good ones, so if you weed out the bad ones from your training set, it's only score.
Because you would think this would be, if there
First
was
you
a
make a
salt
model to
here,
detect
you would
bad
think it is
data.
somewhere here.
Yeah,
Take it
just
out.
throw.
Then you train your actual model.
Yeah. Cause if they
Yeah.
were more careful about
This
what
is,
they're
this is
actually
my
testing.
fear with all the Kaggle competitions, is that the data is not actually as curated as you would
Yeah.
hope it is. And the people who are doing really well just go through and curate their own training set based off the full training set.
Full training set.
Because
So,
stuff like that is just gonna make your model worse, because
Yeah.
it's gonna get penalized for
Yeah.
not,
not
like,
being able
doing
to
the thing
distinguish
that is wrong.
this.
right?
Yeah. It's like, because that's why people are talking about, hey, there is some pre-processing nobody's talking about, and then there's some post-processing people are
Has
doing.
nobody talked about how it just looks weird in the
No,
kernels?
no,
I'm sure.
they probably
It's hard
talk.
to keep
yeah.
track of what everybody says
Saying
about the whole competition, right? It's like
competition,
another
yeah.
full-time job, just
Yeah.
to read all the kernels and all the
Yeah.
discussion. I felt like, at least with the, what was it called? The data science, or the science?
Science bowl or something, yeah,
Yeah, like the data science bowl.
Yeah, the one that like was more academic.
yeah,
Yeah.
The guy who was in charge of it, that was the one that was, they were trying to find the nuclei in cells. The guy who was in charge of it was not prize eligible, but he was like posting blogs all the time about what he was doing and how he was doing things. And he kept up on all the forums. And so like if he was talking about it, it was basically a digest of what everybody else was talking
Yeah.
about. You almost need something like
Yeah,
that,
you
because otherwise it's a full-time job to keep track of
Oh,
what
yeah.
everybody's saying.
like this one, hey, there is a
And maybe
mask
it's worth
here,
it
there is a
if you
mask there,
Are earning $30,000,
Yeah,
$40,000
now
per
the
competition, but
addition, yeah,
if you're not winning
I
them,
mean,
then
they're paying
Yeah.
out what, like the top 4 places.
That's all.
I think.
that's all.
Yeah.
And then the fourth place gets probably $10,000 out of this.
yeah,
And,
it's not much to pay the bills.
But it's I mean, the only thing is you get some data, you get to play around with it, you can do the things and stuff like that. I don't think, you can't, I mean, these are all straight stuff. So I just don't know what kind of, I mean, should I throw stuff out? Like, I mean, it's easy to find and throw stuff. I mean, I can write a logic to say if it's a straight line here or something. throw it out. But is it worth throwing it out? I don't know.
There's,
Are the non-verticals, like, there's a straight line right there, third from the, or second from the bottom?
so.
Yeah.
Straight,
This one?
yeah, no, down, yeah, right there,
They're there?
to the right.
They're right, yeah.
So it's straight, but it's not,
It's not straight here.
no, it's a straight line, it's not completely vertical, but it is a straight line, right?
Mm.
Compared to the other ones, like to the
Yeah.
left.
Oh,
which
yeah,
are not
compared to that
straight the
other
right.
one, yeah.
Like, is that valid? Because you can probably easily find completely
So,
straight verticals.
I think
and
there's
remove them.
another approach that might
Ah.
yield fruit here. You train up your model, just like you trained it up now with everything.
Yeah,
And you find out which images it's doing the worst on. And look at those, because those are probably the fishy ones. And then
oh, train it like say, I mean,
you're already training it, right?
yeah.
And you score how well does it do on every image. And then you just start looking at the ones.
No, that's what I was looking at here,
Yeah,
see?
I feel like
You can see.
here you could say that your model is picking up bad habits because it's got part of this mask, right?
Part of the mask
like-
here and there, see, yeah, that's your
I
image
feel
we
like
talk
that's
about here.
it.
That's-
Like picking up that.
That's why your model is better.
Yeah, this is exactly one we saw where there is a mask on this side and a mask on the side. and then-
Oh, the one on the upper right also. It
Yeah.
did predict that.
So I think you
That's-
just iterate on this.
It didn't predict
You look at
anything on it,
these,
yeah.
And you
Yeah.
say, oh yeah, this is showing me that
This,
You know,
this
these
one
are
has the
the
same
ones
effect.
that
Yeah,
I can't learn.
yeah.
So you take them out and you train again. And you keep doing it over and over again. So
Okay,
you stop seeing things that look funny.
What about the ones with the tiny masks?
yeah, the tiny mask is another problem.
Yeah, leave
Yeah, I
those.
mean, that's.
See, this one, it's not able to predict anything, like, which is a straight thing like this, which is going across straight.
But that
Plus
kinda
it's
looks
got,
realistic.
it's,
Like, I would believe
that's,
that.
that's probably, and plus it's got a green here too.
No,
in the middle.
I believe that.
Okay,
Yeah.
yeah.
probably not gonna catch that little face.
No.
That looks
No.
at least naturalistic. It doesn't
Yeah.
look like these weird artificial
Sure,
straight lines.
things.
That's probably true with the full green too.
Some of the full greens, yeah. Like this one, yeah, it certainly has trouble with this mask here, which is again that straight mask here.
That's wrong again.
But the other ones that are full green.
What's up with these white lines? I don't understand why they're shifted.
What are
Which
these
one?
white
All the
lines?
squares.
Yeah, your little guide.
This
grid
one,
lines.
that's just the grid line. I gotta get rid of the grid lines.
Okay.
That's not part of the image. When I was plotting
No, I
it,
imagined that they weren't, but I
Yeah.
just didn't know why they were there.
Oh, like,
yeah, I just have to say
Yeah,
grid
turn it
off, turn it off. I mean, it's, thing is, it just does that. I mean, here, the model predicted a very tiny one and it was a zero masks. And so then you don't get any mark, any score either. You get a zero score because when the mask is zero, you gotta predict zero.
But that's easy for you to filter those out.
Yeah, that is easy to filter out. Well, where do I filter out is the question. I mean, what?
So,
thing-
okay, I don't know, maybe we're having different
Hmm.
conversations. I thought the goal was to curate a list of good image mask pairs
Oh, yeah.
for training and eliminate the spurious ones that we think are bad.
Oh, yeah, yeah.
But there's 4,000 of them, unless you
Yeah.
want to go through
Oh, yeah.
every
No,
one of
we
them by
can't, we
hand,
can't,
that's
we
too
can't.
much, right?
Yeah.
So you train up a model.
Yeah,
And
like
you
this
look at
is
your
this is
worst
another one.
ones,
Yeah, these are
but
again
you also
worst ones.
exclude the ones that have less than
Mm.
2% coverage, because you know that you're just doing bad on all the ones with less than 2% coverage. So if
Okay.
it has more than 2% coverage and you're doing really poorly at it, then look at it and see if it's one of these cases where they're just like weird vertical lines and stuff. And then maybe
Okay.
throw them out
Throw them out of the training. Okay.
and then train again.
Train
And see
again.
if you get a better overall validation score.
Okay. Okay.
And
Yeah.
then see if you keep getting weird ones that pop up and then
Pop
throw
up,
them
yeah.
out again.
Throw them out
and just
again and do stuff.
rinse
Yeah,
and
that's
repeat
what we
until-
got.
Until you stop seeing weird things.
Yeah. Yeah.
I imagine that it's self-limiting, that eventually you'll throw out all the weird ones after a couple of flushes of this.
But the
And
test image is going to have all these weird ones too. The test images. Why would we think the test image is not going to have all the weird ones?
It might just be more carefully curated, but you're not gonna get those anyway, though.
well,
You're not going to get it anyway.
the other thing
so-
you can do,
You're still
Yeah.
gonna get a better
Like-
score.
Yeah.
there's a
Even if-
forum where you
Yeah.
can talk to people. So you
Yeah.
do this a couple of times and then you go and you do
The
the same
Kaggle
procedure on the
Yeah.
test data.
Yeah.
And then you say, are these real Like, right? Show a couple of them and be like,
Yeah.
is this really what's going on? And then if they reply and they're like, oh yeah, thanks for bringing this to our attention. We're adjusting the data set to
Yeah.
better reflect
So let me talk
real
to
data.
the geology expert.
And geology.
Yeah.
So like, or they respond and they're like, yeah, this is real. This is something that really happens or whatever. Then we know that we have to train on those. But like, I suspect that they're just not real.
Yeah, but how are you going to get a mask thing coverage of 0.001 right? It's very difficult to go and get a spec right there.
I don't
It's
think
not-
you're ever gonna get.
You're ever going to get those things, yeah. So it's, as you say, mostly try to get rid of these weird images where you know these looks
But
weird
at the
and
very
stuff.
least, you post and
Yeah.
then people
Yeah.
respond. and
Oh
then
yeah, I got to
start a
post and stuff,
conversation.
yeah.
If no one else is talking
Yeah.
about it, start the conversation. Probably
Yeah,
a
yeah.
lot of people are thinking it.
Thinking
it,
yeah. It's just, People think that, I mean, I'm seeing in the Kaggle competition, think that they're giving away ideas when they talk about some things and stuff like that. And then there's some firm called,
I figure if you're not in the top 10,
yeah, you
then
better talk, yeah.
you
You're
better
never gonna
talk.
talk, yeah,
because
yeah. There's
the
no,
people in
yeah,
the top 10 aren't going to
Yeah,
talk.
talk,
You
yeah.
want to get into the top 10.
Yeah.
So
yeah.
Even some of the more naturalistic looking ones just don't look like the one that top right, not the very top right, but the one next to it. That point.
This one?
397 one. To your right.
To my right here,
Down one.
down one. Oh yeah,
Like,
this is not getting right. I just have to see why, yeah, again, though,
wait.
this
Oh,
thing, you
that's
should
right.
get it right.
The red is. Wait, so
No,
is
green-
the
No,
red
green is the
actual-
thing. It is not getting, it is saying 0. It is not masking it right.
Yeah, I'm just saying, like, I don't.
The mask is
the
not,
green mask
doesn't
The
make
green
sense.
is the actual mask,
Yeah.
and it's
I'm
not
just saying
predicting a mask.
That doesn't look right. to
Yeah,
me.
yeah.
Like that green mask. It
Yeah.
looks mislabeled.
Yeah,
Like, not that you were wrong and not predicting anything, but just that it
okay.
was not labeled correctly.
like here, okay, the mask is very little, but it's predicting a huge, higher mask than what the actual mask is. The mask is only here.
Yeah,
But
if you
it's
shifted
prediction.
that green like off by 1, this mask might go with this image. Are you sure that there's not an off by 1 in just in your display logic on
I
your
don't think so.
drawing?
I can
Some of
check
them
on
look
that.
More like the one that's
Don't
above
think-
those two. That 0.0921, like that
Yeah.
aligns with some stuff.
I mean, it aligns with this, except that it didn't
It's
go,
like some of them-
but look at here. It has to predict this and it has to predict this.
Yeah, that looks lined up.
But yeah, like,
It lines up pretty well, but it didn't go far enough, and it didn't go and predict this edge mask here. So-
Some of them look really great and they're all lined up,
Yeah,
and the
like,
others
even
just
like
look
this-
weird and like unrelated.
yeah, like I feel like if something should be masked, like
Yeah.
maybe the bottom portion of this image. Like I don't know.
Like this is putting a small speck there,
Yeah.
and then you get a 0 score because you put a small speck there. Because it shouldn't have predicted any mask here.
They're saying the whole thing
Is unmasked. There is no mask in this. There's no salt in this, they're saying, for this image. Yeah, I have to label the images with the name and stuff so that we can go back and stuff, and I gotta do a few more things, but at least
So
now
if
I'm
there's
getting,
if there's 0
yeah.
masked,
And if you even
Then what
predict
is
point,
union?
even if you predict 1 pixel, you're done. You don't get a mark for that thing. If it is a 0 mask ground truth, then you have to say it is a 0 mask ground
Their
truth.
scoring is not very good.
Yeah, it doesn't-
No.
It seems like a weird metric.
Yeah, they precision metric. It's a very precision metric, and then they say that if there
But
is a
then,
0
like,
mask,
So does if you're off by if there's say they have a mask that's like 1 pixel, so it's like 0.01 or whatever.
Yeah.
And you said 0, you get a 0 for that one.
0 for that
Does
one too.
Count the same as getting a 0 for one where it was like a huge mask and you just didn't see it.
Yeah, it's the
So
same
they
thing.
count- Yeah.
Yeah.
that's making sense.
yeah. So
Yeah, it's
so they give you a score per image,
per image, and then they average the whole thing out.
and so you can be really good But if you put one pixel into a thing that was supposed to be all white or all black,
Yeah,
then you get 0 for that image. But then if you had, if you predicted this weird shape and you got it to like really good accuracy,
yeah,
and like you predicted exactly
Yeah.
this, and you're off by 1 or 2 pixels,
you still get a
this
good
image
score.
scores
because the
as
score-
much as the other.
Yeah, the other image thing, you get penalized for that. That's why, I mean, the leaderboard is not going to go much beyond this 0.85 point. I mean, that's why you're not going to, because look, the Carvana thing, they got on to 0.96, 0.97, 0.98 and stuff like that. I think
Yeah,
0.96.
well, because every
Because-
image in Carvana had
Yeah.
some without and some
Some
with.
with,
So
yeah.
there was car and not car
Not car,
in every image.
Yeah.
But when you have images that are just like this,
Weird,
it's
yeah.
all in there, then
Yeah.
like you predict 1 pixel,
Yeah.
your score goes
Goes to the thing.
from 100% to 0.
Who made that metric?
Well, that's all they
I think the
made
metric makes sense on these big images, right? These 10,000 by 10,000,
Yeah.
because there's always some salt and some not salt. But when you chop it up into these little bits, you need a different metric.
Yeah, like there was this case where there was like a very small coverage and my prediction didn't do the coverage, so you get a 0 score on this. So anyway, that's the competition. We can't worry about the competition, but as you said, I can go through this and throw out things where it's really not those 0.01 point stuff, but where it's not getting it right, like here. Like this side and this side. It's trying to get both sides, but it just didn't get it far enough to cover
Maybe you
50%.
need to game the system a little bit, right?
Mm.
Because you know that their metric is funky.
Yeah,
And just building a UNet that does per pixel labeling is gonna lead you to a bad score.
yeah.
But what if you were to classify the images first
Mm.
into a has boundaries and has no boundaries
Okay,
case, right? Like these cases where there's no boundaries, like the whole thing is all the same, are causing your score to go way down.
yeah,
But if you can weed those out first
okay.
and only run the UNet on things that you want to do per pixel labeling on, all you have to do is you basically have a classifier.
Yeah.
So
What do you say?
It has 3 classes. It
Yeah.
has all mask,
Yeah,
all, well, I guess all salt, all no salt.
yeah,
And mix.
okay,
So you have a 3-class classifier that runs first,
okay,
and then you only run the UNet on these ones.
okay.
And then your salt, no salt, you just trust that classifier to have gotten it correct.
Oh,
I bet your score would go way up.
Oh, just used it. So you classify the image classifier. Basically, but run a normal classifier like we do the
Cats, dogs.
dogs, cats thing.
Yep.
Just do a classifier, say all salt, all no salt and stuff, and then
Yeah. Because you
Yeah.
can easily build
Ah.
those labels of salt,
oh yeah,
and
easily.
salt and mix.
Well,
Run through, make your classifier, and make a 2-stage process where you run this classifier first, and then you run the UNet
Yeah.
on the rest.
oh yeah, right. Because there is a bunch of stuff in this thing which has there is no salt.
Yeah, there's
Yeah,
quite a few
of them
that
which
have
has no
0 pixels
0 pixels on them.
that are different from one another,
Yeah,
right?
yeah. And then but there may not be much on the other side of it where we are saying, because I'm not seeing complete white. See,
There's got to be some in there though. Maybe there aren't. I don't know.
maybe,
Like
yeah.
maybe all salt is 8% of the images,
Mm.
and this is 0% of the images.
No salt. No. Black is no salt. There is a bunch of masks with no salt.
Oh, so it's like this. It's like
Yeah,
0%.
yeah, 0% or something like that. Yeah, no, that is
But that
something.
gets you like an 8% increase in your score, like right there, because if you can identify those.
If I can identify,
with
let's
pretty
see
high
how
fidelity.
the classifier can do a good job.
Yeah.
then that can really help if you can do that. If I can do that, I can run a classifier easily. Just run a ResNet on it, see how it comes out. I mean, easy to classify this. But say here, this is where you're gonna, like this one.
Yeah, so maybe it's
See
not
this tiny
really
one
three
pixel,
categories as
there that has a salt, you're never gonna be able to predict that. See that tiny thing?
Yeah.
And they give you a zero
I
score.
wouldn't worry about predicting it. Because I'm sure
Yeah.
some of their test samples are like that, but
Yeah.
it's almost like not worth it.
Yeah. But there is a bunch of stuff that has complete salt. So that may be worth, see here. I mean, this, all this saps, no salt here. No salt.
Well, there's the little one.
Here, yeah. And then this one is an island here, sitting here. No, the classifier would be great, I think. I mean, it's not even 8%. I think it's a higher percent where there is no salt in there. I'm looking at it. You
Well,
just
where's
see a
your,
bunch
it's,
of stuff. There's no
you
salt
showed
in
there
it.
was like 450 images that had zero coverage, right? You had
No. That one was, that one also, it is not a much. Why did I say that? No, that was a different histogram. That is where the image itself was 80 images or black, not the mask.
You had a histogram of coverage.
For those images.
No, here, that was a coverage on the images, not on the mask.
Can you go back to where you showed us that?
Oh, this one. I was showing you some histograms that I was doing and stuff. Here, that is.
No, keep going up. This is not the one I was talking about.
Oh, okay. This one, maybe something else on this, on the Google Colab thing. Let me go up. This one. That's all the figures I have.
Maybe it wasn't your figure, maybe it was somebody else's, but there was one,
Hmm.
I remember really clearly that there was one box over here. That went up to 450,
Okay.
and then there was a long gap, and then there's a really nice smooth Gaussian over here. And I thought it's right.
Oh, yeah. Yeah.
And I thought that was like percent coverage of.
No, was it? Okay. Let me go here.
There's like one of the first things you showed.
Yeah, the kernels. Let me go on
Someone else's kernel.
someone else's kernel here. Salt coverage. See here? This is the one, you remember? The coverage is,
This is not the plot I was referring to.
okay, this is not the plot, but it does show you the salt coverage for how many of them? I mean, out of the 4,000, 2,000 have no salt coverage
Or fall into the smallest bit.
or following in the smallest band. This is the depth distribution. So this may not be it then. You're remembering a different graph.
Yep.
Okay.
Yeah, I thought it was
But-
in your notebook.
Okay, 450.
There was also, in addition to the outlier at the very bottom, there was like a tiny outlier at the very top too.
I don't know which one was it because I was just playing around with this coverage to depth and stuff, and this wasn't getting me anywhere. So, but anyway, I mean, it's not just 450. I'm saying, telling you is that salt coverage, yeah, it may be 450 or more. Could be, yeah, could be 450. I mean, they're saying
So 450
2,000,
puts you in like the 10% range.
10% range. If it is all, yeah,
That's what it
450.
is. But
Yeah.
like, getting the correct answer on 10%.
Oh, huge, because remember I'm showing you this is where I was getting it wrong here. See this this is what you would remember. This is what you remember. See here? Is this what you remember?
Yeah, yep.
That's a different, yeah, that's on the image gray. Yeah, but that is again, I'm telling you is on the test, this is on the images, not on the masks. This is on the images. I was just saying, what are the pixels in the images? I was averaging out all the pixels in the images, and in the images, this was in the test set, like there were 500 images or something like that, which was all zero mask. Yeah, don't even do the unit. I see what you're saying. Hey, don't even do the unit. As long as if it can distinguish between a class of this or that, you may. Oh,
Sorry.
oh, there's some food.
It's all
Oh,
vegetarian, by the way.
Oh, right.
Where is this?
No, this
In
is.
the kitchen, that's the other side of the.
This is interesting. Yeah, if you can do this,
Yeah,
if that can even identify even that class in
Yeah,
any fashion, that'll be great. Then I can.
Whatever
follow
meaning
that
got out
format.
and
This is not, as I say, this is not 8%. This is
Too
probably
scared.
going to be in the
Okay.
15-20%
Anyone
range.
you wanna get it?
That's even better.
Yeah, they're- I
the
mean-
mask thing. Yeah,
from
okay. That's pretty
From my
good. Yeah.
experience.
Because
at
why even
work,
do the unit?
any-
Unit is
any-
never gonna
If they put
get
food in the
this
kitchen.
full
it's
coverage
okay.
and all that stuff.
Like,
Why
especially
are
on
you
the
trying
table
to
where
do that?
No,
It's
you
true,
have to
that's-
decide, like,
No,
units
not
are
gonna
kind of
stay
designed
right.
to do this mixed case where like some of it is and some of it is.
Actually, I'm so sorry.
Which, yeah.
But it's
I see
not
all
gonna
the
tell
time.
you the whole thing is. or the whole
Yeah.
thing is.
I'm so
bad
yeah.
Like, it's not built for that. It can maybe do it, but it's like asking it to do something it doesn't wanna do.
Yeah.
So,
I should probably go get
like
some
a classifier, do that part first.
First, yeah, and then go from there.
And if you get in the money with this, I expect a little kickback.
Yeah, I know. I'll
Like it's
consider
a
money.
consulting fee.
Yeah,
You
yeah,
expect a cut.
because this is a great idea. I've never thought about.
What was the idea?
The idea is instead of trying to build this unit on this whole, all these images, we know almost 15-20% of the images have no salt. Because if you look at the mask, it's all black. Lot of masks are black. Lot of masks are black. Why even train a unit on this on trying to predict the whole thing has no salt in it? So David's idea is build a classifier,
Separate model.
build a classifier, classify that out, and then build a unit only for things that are not in that class.
Yeah. And if you
I
have
mean,
none of them that are in this all salt category, just do a 2-category classifier.
Yeah,
instead of a
2
3-category.
because I'm trying to not, I mean, I'm looking at it, I hardly find anything. I mean, even here, but then see there is a black here. See, they put a black here. That's the thing. I mean, that gets very hard to go and predict that. Yeah, very little of all salt in there.
And it may just be the case that they chose the size of image being like 100 pixels by 100 pixels so that you don't ever have any that are all salt. Like it seems arbitrary to choose 101 by 101.
Yeah, because why would you have chosen 64 by 64,
Yeah, yeah.
128 by
And so it might
128?
just be the case that they're like,
Yeah.
what is the size that we need in order to make sure that they're not all salt? But they didn't think of, there are gonna be a lot of them that are all no salt.
Yeah. Yeah. Yeah, I just don't even find,
think
it's just two
social
classes.
engineered, like how they decided this 101 and 1 by 101. I bet they took these big pictures
Yeah.
and they looked at a bunch of them and they were like, if I draw a line from this point to this point, like how big is it? It's like 101 pixels. That way I can guarantee that there is never a case that I draw a box anywhere here that is all salt. And then they're like, all right, that's how big we're gonna make it.
Or they thought it would be easier for the convolution, so you don't have to pad it.
Some weird thought like that.
But I think that's,
Because they have
I think
100
it's not
by
a
100.
coincidence that you don't see any that are all white.
There's one. You just said there's just
There's like
one.
one pixel
One.
out of it.
Oh, there's one pixel?
Yeah, down at the very bottom.
Oh.
Right?
Oh, yeah. There is a small black.
Yeah. No, you can use this to your advantage. You can
Yeah.
basically say,
Yeah.
If I was gonna say all salt, just throw a pixel in there somewhere because, like, you'll never get the right answer if you say that it's all salt, right?
Yeah, you'll never get the right answer if you're all salt.
No, wait, you'll get a really good answer if you say all salt.
Yeah, you
Because
get a really good
intersection over
because
union is really good.
It's really good. So you don't get penalized for that.
Yeah,
It's
yeah.
only
So
the
actually
other side you get penalized.
put everything that has, less than, I don't know, 2% coverage into this all salt cover, or I guess-
No. You're less than greater than 98%.
Yeah, greater
Greater
than
than
95%, or greater than some largest percentage.
percent. Okay, because you don't get penalized for that. You'll get pretty close because the
Yeah.
threshold is at
You really
0.95.
get penalized only for these no salt cases, not for the lots of salt cases.
Yeah,
Yeah, I think this is gonna be key to getting up the high on the.
higher.
How high are they getting? Because this.
0.85 is what they're getting. That's the
Okay.
highest right now in the money, is 0.853 or 0.854
Yeah,
is in the money. And
this seems like,
whatever people
this
have
seems like a
published
big
units,
fix.
things and all stuff, it'll only get you to 0.75 or 0.76. I mean, just the general
I think
unit.
this is gonna get you into the point.
Oh, okay.
I don't know.
I don't know.
This seems
Let's
like
see.
huge to me,
Yeah,
just because you're kind of gaming
you gotta give them the metric.
the metric,
Yeah,
right?
yeah.
Because you're saying things that are almost all covered, there's no penalty for guessing a little bit wrong.
Yeah.
Because you're getting 90-something% because you're just guessing the whole thing is covered.
Yeah.
With this classifier, you just tell it everything in here is covered. And the 10% that you get wrong is like still getting you a pretty high score.
Yeah.
Whereas here, if only 10% of it's covered, or
Even if you leave.
or
if
almost none of it is covered,
Yeah.
then you just treat them as all blacks. So all the things that are all black or almost all black.
Yeah, there you'll get penalized quite a bit. Okay, that almost all black, if you don't predict it correctly,
Yeah, if you say
Even
that's
if you
all
say-
black, you're in big trouble.
you're in big trouble. Then you're zero score.
Yeah.
That's why you have to weed out all black out to the classifier and make the unit has to predict. I mean, the unit has to at least work on this other thing. Wow. Is there still some food left?
there's a lot.
Oh.
It's from some kind of,
Where is it? It's on the other side?
It's some kind of meetup that's way better than our meetup.
It could feed like 50 more people.
Really?
Okay, maybe not 50.
nothing there.
How did you find out about it? You just
Huh?
went to the
I was-
restroom and noticed?
I saw the lady.
I was going to warm up my tea because
Oh, okay.
I got the tea and then I realized it filled it up with cold water even though I pressed hot.
Sorry,
So I had to
Dave,
warm
we
it
got
up.
food. Probably online watching what happened. Yeah, everybody left to get food.
I'm surprised it's all vegetarian though.
Yeah.
I mean,
made
not-
a mistake with that water
Huh?
dispenser though.
What's it? No, I did press hot.
It didn't, because it's like green and then it switches to orange when it's
Yeah,
hot.
I saw that. No, I think it stopped heating.
Oh,
I saw it. I switched
Because
it.
I put like cold water in my oven because I forgot to like switch it. Because the default is like cold.
Microwave. Oh, I didn't see soft tacos.
Oh, yeah, no. It's already 7:15. Yeah, we probably should start talking about
Yeah.
future plans of this.
Yeah, I don't know what we're gonna do.
So we were just talking maybe you can alternate between everyone. Other than then everyone can
Everybody takes a week.
contribute. Like, I mean, not mandatory, but
Would work.
I don't know if we have enough people as advanced as you guys. But
Well, I feel like I said my piece sort of online or whatever, but I feel like I need at least 6 weeks to kind of step away.
oh yeah, are you still going to be coming? Or
I don't know, like, In some ways, it's not very costly to come because it's like the evening, and if I don't come, I would be doing kid stuff at home.
Yeah.
And so my wife can do the kid stuff instead of me. But then, so these hours are kind of free hours,
Yeah,
but
it's just
anything
the
outside
prep,
of, yeah, any
prep
prep
time is, yeah, I
or
understand.
any
totally.
other time is not.
Yeah, it would be good if you still came and, you can suggest a lot of things when somebody else is presenting their model or whatever lesson.
Yeah,
Yeah, and I mean, depending on what the format is, like it doesn't have to be 2 hours either. Like it could be 2 hours every other week or like 1 hour every week. Or like,
yeah, no, I think
Mariana actually was
if-
talking about making it more often.
really?
I think if people are interested and want to do it, that's great. You just have to be assertive enough to like, butt in over the top of Narayana a little bit. Because if given 10 seconds of silence, he's going to start talking about what he's done this week.
Well,
So, and that's great. And he's fun, but I think he can be domineering without
Yeah.
meaning to.
Yeah, like maybe, yeah, like, do you think there would be enough people willing to present stuff every week that it could take that kind of format? Would it be like presenting just like?
Well, I know
different
Mila
things you
actually
want?
has real results to show. And then Deke probably will soon too.
Yeah, and I could soon as well.
Yeah, I mean, and then if you think about it, if there's 6 of us, 5, if you don't count me, like you only have to do it every 5 weeks or every 10 weeks, depending on how often you meet. So like,
Yeah.
10 weeks is a long time to work on a little project.
I can participate. Only problem is, I don't know if I can do any more outside of here because I got the wash shoot thing now. So all my free time after work, I have to do wash shoot and then weekends wash shoot. So.
So
Charter
can you
doing it.
present the work that you're
I
doing
can.
at Charter
Yeah, I
or
just
at
won't be able
WashU?
to prepare outside of it. So, but I can present my work.
Yeah, I think that's what people are talking about.
Work, then.
Yeah. I mean, yeah, I'll let you do. As long as it's okay with, I mean, they shouldn't have an issue, right?
Well,
Yes.
Charter might,
Charter,
Yeah.
Charter might wash you.
but WashU won't.
Yeah, okay,
Right.
then that's fine. Because a lot of their research papers are online.
Yeah.
Yeah,
So I can just present that stuff. Okay. Yeah, I can do that.
yeah. You can be like, look at this paper I got published in Nature this week.
I don't even know that Charter would care, to be honest. Like, they're never gonna know. There's 6 of us in here. It's not like we're gonna start up a business to compete with Charter. And then like,
No,
Scoop them on their
it's
data or
probably mostly not IP. It's probably mostly the personal data.
Take
If
all the risk.
what's
it's-
that?
We'll let Deke take. all the
Yeah, that's
risk,
right.
and then we'll
Just don't bring personal data in.
Yeah, don't be personally identifiable data so that you can like
Yeah.
hound people.
PII.
But a lot of that you probably don't even have. A lot of what you have is just like aggregated metrics on sales and stuff. Yeah, that's fine. I don't think anybody in here is a significant stockholder of Charter or short Charter. Like, they're probably not gonna get FCC
mine.
involved.
Did anybody join? What about, so I'd asked Narayana about this. Because I don't know if he had any interest in tackling any of the stuff in part 2. Because I've studied a lot of the RNA, CNN, that stuff. But I'm really interested in learning about like autoencoders and GANs. Because I never get to do that a lot, you know. But that's a whole other world that they talk about that we haven't even discussed. It'd be kind of cool if we could, since we've done most of part 1, it'd be kind of cool if we could take a look at.
I can talk about autoencoders.
Yeah, that'd be great. I
Maybe
feel like
not
that's
next
stuff.
week, but at some point.
It's something that you
Work
wanna-
with those.
That's something you wanna do or have done?
I have done and I want to do more of.
Yeah, I mean,
Yeah.
if we're talking about potentially 10 weeks out, I could probably
Yeah, because you did
present stuff on Waldo stuff, because
Yeah.
it is my plan to eventually start engineering all the Waldo stuff, or I can even just present on what we're doing right now,
Yeah.
which I don't know that is like super proprietary or like fancy. So
I mean, even your like variational auto encoder stuff, like that's really interesting too. Like some of the stuff you triple, even instead of just like recreating a paper.
yeah. So while you were gone,
Yeah.
Marina,
Yeah.
Andre suggested that we each present. And so instead of doing the Fast AI course
Yeah.
reboot, since
Okay.
maybe nobody is interested in that,
So,
we just take turns presenting
okay.
or every 2 weeks or whatever.
Yeah. Okay, presenting some interesting stuff that we've seen or.
Up to
Done.
whoever wants,
Okay.
like, if it's your turn, you present whatever you want to present.
Okay.
And you have the floor and you get to do whatever you want to do.
Present a notebook of
Yeah.
either a model, hopefully a model,
Yeah.
Yeah,
or
but I think everybody's interested in slightly different things, and so that's actually
Oh, yeah.
a really good idea, because
Yeah.
Deke really wants to do GANs, but we haven't
Yeah.
covered GANs, and so if you
GANs are
study
really-
GANs, then show it to us.
Yeah, if you've done something on GANs, I mean, show it to us and we can then start the conversation from there rather than go through the deep learning too. I know you'd asked about that, then I'm thinking, okay, should we sit here and cover deep learning too? Because that's more advanced stuff. Instead of that, I mean, if you're working on something,
Yeah.
I mean, obviously, you don't need to bring your work stuff inside, but the GAN's gotta be something that you're training or you're trying to do something with the GANs and things which are, then it'll be a good discussion. Hey, what are you trying to do? And okay, can you do it differently? And what results are you getting? And I mean, we've gone into main thing is this Fast AI was, okay, here's how you do deep learning. Hey, you set up the deep learning, the learning rate is important. You have to switch over schedule the learning rate. You have to cycle the learning rate, have different learning rates for the different layers and stuff. And those are the training methodologies. I mean, he really introduced in the deep learning one thing. How do you do this? Yeah, there are flavors of all these architecture, the RNN and the classifier and the regression models and I was going to ask you about that regression model. When I looked at the Rossmann, he's actually sending in the sales into that model. Remember, I mean, we talked about when I was talking about, hey, you want to send 0 to 1 in there and stuff, and that helps when I looked at his Rossmann model, he's not scaling it down.
Yeah. Check it out. Yeah.
Yeah.
Hopefully we won't get it. That's like they were gonna do. Whatever. Yeah, shut down. What was that issue? like a couple years ago or something, yeah.
I feel like.
Every now and then they get a scare.
And I figure if I ate Chipotle every single meal, every single day, like my odds of getting sick from that would be like ridiculously low compared to if I was just like making my own food. You know?
I wish you could get there somewhere to get some of these, event, like, Bosco or somebody come in. Maybe, I mean, just once, maybe.
What?
do a presentation.
Who?
Like Bosco, you know, some of these more.
Yeah, I mean, we're doing it, but the problem with Bhaskar is he can't talk about things he's doing within Monsanto. He runs into a problem with that. Then it becomes okay, you can only present some very general stuff out of that, and we question him, he can't say much. And
I like the one you did where we all met, the one at Monsanto.
yeah,
That one was good.
What are you talking about then?
It's about like lightning spaces.
The,
Representation learning.
Yeah.
what is it?
Representation learning? What, he was asking, what did they cover when?
Yeah, okay.
when,
Oh, yeah, he was saying something about how it's becoming a hot field there, the representation learning.
Yeah, I mean, it was a really high level talk. He didn't get into any code or any specific
Yeah, oh, yeah.
examples. And it was maybe too high level to be of use unless you're already indoctrinated into the field a little bit. Like,
I feel like the crowd was pretty, there were a lot of people in the crowd that just like, it was too low level for them. I feel like.
it was too low level for them, but too high level for.
Yeah.
Oh, okay.
Yeah, I don't know. It's a tough thing. Like in hindsight, I think a lot of what he said is really interesting and deep concepts in the field,
Yeah.
but
We didn't talk about this.
there wasn't any like. It wasn't accessible to act on in any meaningful way.
Yeah, I feel like he just didn't, I feel like give like real world specific example. Like he gave some like analogies, but not like he talked about what was it, a chair, like a table, and like the
Yeah.
legs or legs and
Yeah.
stuff like that. But didn't focus as heavily on application.
He just wanted your appetite then.
Huh?
He just wanted your appetite.
Yeah.
Well,
Yeah,
it's like
that's
any
the-
proposition then.
I don't know. I mean, should we? I mean, I can ask Bhaskar. Should we have another meetup with the bigger group and stuff if he has something to present? And because he's wanting other people to present, and apparently he's had no luck with that. And so on some of the whatever his thing was, okay, let's talk about some of the developments here and things of what is going on. Unless I don't know if are there a lot of WashU students doing deep learning stuff that you're aware of that they can come and present in meetups and stuff? Because this professor must be doing some research work and things, and
Yeah, it doesn't have to be one of us six. It can be
yeah,
other people too.
Well,
because we can.
about online, that there's some meetups that we could,
Yeah, the FastAI meetup. Yeah.
cause like when I went to last year, I was in Silicon Valley for like a week. They had meetups like daily, everywhere. There's so many.
Yeah, so many technologies. Yeah. Yeah.
Join,
Yeah.
or connect with them.
Yeah.
Like, you
Yeah, but they're not necessarily going to go at the pace that we want to go.
Yeah. That's
They
the
may be
thing.
going too fast or too slow, or they may already be like on week
Because
50 or
if
week 8.
you-
Like
if you see here,
Twiml AI was doing one, like as a big group. But I noticed that they're already on like week 5. Like they've been meeting for 5 weeks already.
which one?
Twiml AI, this
Oh.
week in machine learning and AI.
Okay.
It's a podcast.
Yeah. I mean, we could go
So
in
they-
there and
Their users are all engaged in the Fast AI course lesson 1 material or course 1 materials. But they're 5 weeks into it, and I don't know if that means 5 lessons into it or if that
yeah,
means
you don't know that. So
Yeah, so I haven't paid enough attention.
Probably,
What's
you
that?
could,
was it a podcast that, like this weekend? Machine learning?
Yeah, so it's a podcast, but the podcast is not about this. The podcast is weekly interviews with machine learning like practitioners. But then there's just like a little 1-minute thing at the end. He's like, and also to all the Twimmel AI listeners out there, I'm starting a whatever meetup that is totally separate, but it's just like he's using his
Gotcha.
pulpit to like.
see, they started in June again, let's Cleveland, Ohio study group. They said, sign up for this link. Okay, but we don't know if that is a online meetup or something like the Dallas one. They say was an online. Oh, this is the TwinMLI online group mentioned. Okay.
But I noticed they've already got like at least 5 lessons or at least 5 meets. I don't
But
know.
we can look at their recording. I mean, the meetup
Sure.
recording is
I think
available.
we're not limited on the amount of material to cover. We're just
No. I'm
limited-
just saying, but no. Whether they are into 5 or something, I'm just saying, should we
Oh, yeah. we
look
can
at where
answer the
they are-
question, yeah.
where they are in there? Okay, first DAG, they didn't cover much. This is all image classification with convolutional networks.
Which lesson is this? This is session.
This
0.
is 0.
Jump to session 5. or whatever.
I don't know if they have a session 5. That's the problem with all these stuff. Is it whether they have a session 5? I'm not seeing any session 5. Then they had a session 1 recording, but after that they don't have
Well,
any
look on their
recording.
GitHub or their YouTube channel.
Okay,
Or like
YouTube,
all the
this one?
videos posted by that.
TwinMLI. Okay. Here, Twin.
Or I think you can click on
No,
who
just
it
go down
posted.
a little bit.
This one.
Yeah, yeah.
Okay, this one.
That'll be the
No, no,
account.
that's the-
Okay,
that's the-
session 6. So we can see what the session 6, which is just they met recently, August 4th. So like we can take a look at it, how far they are into this. Okay. My audio is 100%. I'm not getting any audio.
You do the closed caption, press that button, or
Um,
on the CC.
So here,
There we go. Oh, rain.
So weird. If it was sunny, rain.
okay, I don't know why the,
This is
Do the
material
TV
covered in the
TV
class.
volume, put it down.
This is not material covered in the class.
in the class, they are talking about associativity. How do you back propagate and stuff like that, I suppose, the gradient and the chain thing of the gradient.
I love the guy who's just like cut off. He just looks like, oh.
See, set up here and he's going to feed for, okay, this is all not. Okay, this one is now hide, okay. No, the sound is not coming. Okay, so they are talking about few things like this. I mean, we can, I mean, if something, the intuitive thing, that's good.
Would it be a waste of time to watch the rest of the videos and then just pause and talk about it over a couple of weeks instead of like spending a whole hour, 2 hours watching the video? But we watch it together, but then it's pause and discuss the concept that he's going over.
That's not a bad idea
And
either.
then we could learn.
Yeah,
the rest of
That's,
it.
I mean, that is a one way on the deep learning too or something, just to learn the I mean, it's very hard to go through the notebook in detail and I mean, it takes a while to,
Yeah, but at
It's
least
just,
if you're watching the video, because a lot of times you watch the video, you don't get it the first time, right?
Yeah,
So if you can talk together and
yeah.
watch it together,
Yeah.
that way, you know, we can spread it over a couple of weeks and take our time and actually learn the material
Hmm.
while we're watching. That way it's not on you to
Yeah.
prepare it. We
Yeah,
just go together. And
you're together,
If you
yeah.
have questions, we pause the video and we discuss it.
Jeez, good.
Yeah,
I guess if
so-
you watch it enough times, then something will eventually settle in.
I mean, he says on average, people watch it 3 times.
You gotta
No, that deep learning two, the first,
There you
the
go.
first or the second video in deep learning two, they said you gotta watch it like 7, 8, 9 times. I mean, people are, because
I
it's
think
very,
it'll help a lot.
because they have to do the box and stuff on
I
the
think
image
it'll
and,
help a lot more if you watch it
Yeah.
together, because then we can talk about it.
yeah,
If
Yeah.
you watch it alone, you don't have to be buying ads. So then
Yeah.
you can discuss anything you have questions.
Probably a mixture of both, and like talks as well as videos.
Because that way we can keep learning. The other option, I just sent you a link.
That's why this is not, the audio was very low.
Did anyone ever dig a little deeper into the deep learning textbook?
I've jumped through a few articles and it looks very good.
No, I tried reading it a couple of months back and I couldn't go beyond the second or third chapter. So I don't know, I think there is, I could only find one study group on the internet which is actually, which goes through the book, step by step an article. So I'm wondering if it would be a good idea to, take that study of that book as a project, which we could do it online because. I thought about this too. So it's hard to carve out more time for that, but but I think
That's
I
the
don't know
most
if
I can
this
tell.
is meant as a book
Recognize
that
his
you really
voice.
read and learn from it, or is it more like a book where you look things up?
No, I think Elon Musk has said that if somebody has read the book, you can get a job in Tesla or OpenAI. That's what he has said.
After we talked about it last time, ordered the hard copy. It's been on my list for a while.
Okay, I can go back and get the.
Yeah, I already have it, so it's lying on my desk for a long time. Yeah.
Okay, which book?
Dimensions flow.
Just a good
Do some
fellow.
also. Thanks.
The newer versions will have better matrix handling capabilities.
Which book is he talking about? I don't know.
That's I think
Okay.
what he's trying to do here is designed to do the same thing for human inception.
Okay, this is all architecture. I can't find the book. I was trying to find the book.
So
So
two ideas people have had.
Yeah,
Either we do individual presentations or we watch videos together and pause. Like we watch it beforehand, but we watch it again together and
Yeah.
pause and pause.
Then maybe.
Or we could do alternate those two ideas week by week. And
There may be one other one. Click on the Slack, or your Slack. I don't know if this is gonna work, because I messaged this guy. Maybe he hasn't checked his messages, but.
join with this other group.
Yeah, because they got like 33 people now, but nobody's really doing it.
no,
I don't know.
don't think about 33 people. Like
Yeah.
this meetup.com, he said that Bhaskar said there's 400 people or something like that in that DL meetup. So those things don't.
I don't know if you could post in the group and ask. Click on the link.
Didn't you already do that?
I messaged him privately.
That's sort of a new though. That's like, that came out. What, a week
Here?
ago?
Yeah, a week. So there's.
Here,
Yeah, I don't know if you can post on their board and ask them what they're planning to do. Or something. I don't know. I mean, we can still do our own thing, but just in see.
yeah, I mean, he will answer you or something. I don't know where to post things. Discussion.
Yeah, you can. I guess you can post. If you join.
You can, I think, contact the
I have to just.
coordinator, organizer.
Yeah, I messaged him, but I think.
Oh.
Yeah. Okay. I mean, wait for him to reply back.
Well, yeah, I can do that.
Yeah.
So,
Wait for him to reply back, and then we'll do. We could ask them what they're doing and stuff, and instead of this here.
I mean, other than that, I think those are good options. Too.
At least
Yeah,
for a
I-
while, and
learn from it, or is it more
And
like
then-
a?
at some point we could reboot and
Yeah, there's this deep learning
That's
book.
why-
See, this is the book they're talking about.
Yeah.
Yeah, deeplearningbook.org. So okay.
the thing that's nice
Yeah,
about the
Yeah.
So it's a lot of customers.
I don't know what he calls it. It's practical deep learning for coders is the first one, and the other one is
There's another
Yeah.
course in the
Advanced or
FCI thing that I was actually looking at too, was, there's a course called computational linear algebra.
Yeah.
So that's also by the FastAI people as well too.
Yeah.
That's more
Right.
towards like the. how
Machine
the
learning part.
Metal, like the underlying, like using all the
well,
frameworks.
there's also
there.
a machine learning course.
Right now,
They
yeah.
have 4 courses. That's
Yeah.
crazy.
So if you go to, FastAI and then search for computational linear algebra,
Computational linear algebra. Yeah.
Yeah,
Online textbook and videos.
there you go. So,
That'll give us the underlying math.
Because he's onto the speed. He's onto
this is not even,
speed.
yes, the speed, this is about like, it's very numerical analysis.
Yeah.
It's not about, to a certain degree, it's about linear algebra, but it's more about the actual numerical methods.
Hmm.
Which is, I mean, I'm definitely underlying all these like PyTorch, TensorFlow,
Hmm.
et cetera, et cetera.
Yeah.
I just saw it, but I didn't know, I have yet to actually work through it and see if it's actually.
Oh, he gets into SVD and stuff too here. So topic modeling, and this looks like this machine learning course. See, compressed sensing with robust regression,
His
linear
machine learning
regression,
course, the very
how to
first
implement
lesson-
linear regression.
Yeah.
The very first lesson in his machine learning course
Yeah.
is random forest. Like
Okay.
it just gets you going like right off the bat.
Hmm.
Machine learning rather than
Okay.
Yeah,
This
all
is
these
more like
courses,
build
it's
up
interesting, it's
to-
like all these courses are more like, start off doing something on the computer and then see what happens and then figure out stuff as you go along. And then
Hmm.
a lot of other courses are just, let's go about the theory, underlying theory,
Yeah.
then sort of see as you.
more mathy, like build up from first principles,
Right.
little things, and then eventually you could do calculus.
Yeah,
Right.
I struggle with that kind of stuff.
Yeah.
So it all depends. Some people like one or the other.
And he's put a new thing. He's going to start the deep learning course one again on October 22nd now. So,
Yeah, so that
Awesome.
means he's at a traditional regular university and they have 16-week semesters.
yeah,
This is a half semester class. It meets only 8 times.
8 times. Yeah.
That's why he has 8 lessons.
Yeah.
My wife's a professor, so I know these things.
Okay.
And so-
yeah.
The course meets 8 times for
Yeah.
like 2.5 or 3 hours per time once a week.
Mm,
So my wife has night classes that do that same thing.
mm,
And so the course will end around December 15th.
Yeah.
And then a couple of weeks after that, they'll probably make the videos available to everybody else. So I would look for the videos around Christmas.
Christmas, unless he's changed something on the deep learning, unless he's going to cover something new. He usually does.
Yeah.
Because
the
deep learning,
and the
first one
second
was
were
nothing.
very
Yeah,
different.
very different, completely different.
Yeah.
But that was also more different because he was using Keras or things, and then he moved to PyTorch
But it
in the
wasn't
second
the
lesson.
same
and
deep learning
material. Oh,
concepts.
yeah.
It was
yeah.
different deep learning concepts,
Concepts,
not
yeah.
the different, not just
Well,
different framework.
This
Yeah.
field is perpetually changing like this. The state of the art, it seems to be just
Well, if it's coming out
every single time.
in Christmas, then if you start part 2 now, that give us enough time to finish part 2 and then get on the new stuff. in
Do a
part one.
reboot in January
Yeah.
Right.
sometime,
Was
and
there-
then everybody, like nobody in the world will have done the MOOC yet, and so we might even be able to tag along with a bigger online community at the same time, because everybody will be wanting to do the MOOC in January.
Yeah.
Are there MOOCs for
Yeah,
the reinforcement learning stuff too?
For the machine learning,
Not the
the,
machine learning, reinforcement learning.
does he, I don't know
I don't
anybody
know.
doing
I
that.
don't know.
Yeah, I haven't heard,
I haven't read much about it.
But which
I want to
MOOC
learn
you're
more
talking
about
about?
reinforcement learning and like
Which-
OpenAI Gym and all that kind of stuff. It's
Yeah, I
really
didn't know if there's
intriguing.
anything- Yeah.
But I don't know of anybody who has course material on it other than like Andrew Ng and
Udemy
Stuff.
has a course, I think.
who does?
Udemy,
Okay.
deep reinforcement learning. I think I could build AI or something. It's not bad. It's by the guys that do the A through Z data science one. It's really good.
It's like, yeah, it's like some like applied control theory type ideas.
Yeah, no, my understanding of the field, which is rather limited, is that they found a clever way to turn unsupervised problems into basically supervised problems
Hmm.
and then just applied supervised learning to the
I sort of see it as like it's
The thing.
like, so in electrical engineering, there's a branch of field called control theory, which is pretty much just like, how do you make like dynamical systems? How do you make things stable? Like say a rocket, and when you shoot a rocket up, how do you make sure it's going straight up instead of just going all around, whatever? So like, feedback control
yeah.
type
But it's a
things.
So I think there it's mostly like a lot of human engineering goes into the feature engineering.
Right, but
And
here,
then reversing those equations to find the
right.
differential equations that underlie them, and then you make
Well, it's the
system
modeling,
data.
yeah, the modeling and then all that, but
So
there's
that's,
something like there, yeah, applying the deep learning stuff to those types of problems.
yeah, that's model-free learning, which I think is like the exciting thing that reinforcement learning can do. Yeah, no, I think that's all really exciting stuff. I don't know anybody who's got topic or content on it.
Yeah,
But if there is content, we can definitely cover that.
We should train a model to
What's
teach
that?
it, teach it how to play chess.
Yeah.
All you need to do is give it rules. Which piece can do what, and you let it start doing random moves against itself.
Yeah, I mean, this is what they did with DeepMind, right?
Yeah.
So there's
AlphaGo Zero.
2 courses.
Say
The
there's
top one is by the
reinforcement learning in
lazy-
Python.
This
How is
stuff
it? Is this
over-
even worth it? I mean, they say 179 and then 999.
So
Yes.
never pay more than $9.99 because you can do Google Udemy coupons.
I
So
think
it's
that-
always
yeah.
$9.99.
Yeah.
Don't ever pay more than. But these are
It's hard to tell, like some of them are of really great quality and some of them are just horrible.
The-
Well, this has
You look at
2,252
Yeah.
ratings and then
that
4.5.
guy is highly recommended, but it's fairly advanced. It's
How is
very
it 80
limited.
lectures in only 8 hours?
Many lectures.
Yeah.
Those-
Is a
Maybe
lecture
5,
like
10 minutes
5 minutes?
lecture. Yeah.
I'm sure that's probably it.
His stuff is very dense, so he throws a lot at you in like a minute, and it's pretty advanced. So that's why I don't know. If you're, I think one of the guys at Mount Center recommended it, but I like the one below that is
Yeah.
a lot easier to follow.
Okay.
This guy.
I said usually they have an intro thing that you can see,
Yeah,
but
you can
these
go up,
guys
scroll up,
don't
click on
have.
the video. There on the right, that little box.
Here, yeah.
play it.
Okay.
His learning style, you gotta get a
Hey
little.
everyone, this is the Lazy Programmer, and I'm back again to tell you about my latest class, Artificial Intelligence, Reinforcement Learning in Python. When people talk about artificial intelligence, they don't usually mean supervised and unsupervised learning. These tasks are pretty trivial compared to what we think of AI as doing, playing chess and Go, driving cars, and beating video games at a superhuman level. Reinforcement learning has recently become popular for doing all of that and more. Much like deep learning, a lot of the theory was discovered in the 70s and 80s, but it hasn't been until recently that we've been able to observe firsthand the amazing results that are possible. In 2016, we saw AlphaGo beat the world champion in Go.
Oh, you
We
want to go
saw
faster?
AIs play video games like Doom and Super Mario Brothers.
Yeah,
all without
let's-
human
he's just
assistance
reading it.
exponentially. 16 courses just on those topics alone. Yet reinforcement learning opens up a whole
You
new
can
world.
actually look at one of the lessons.
That's led to new
Sometimes
and
they're-
basic insights.
How is
both in
reinforcement
the
learning
field of artificial intelligence.
unsupervised learning?
So what material are we going to talk about in this course? What I noticed in reinforcement learning is that there is a huge gap
It
between
labels
what you
itself.
learn theory-wise and what you do during programming.
And then trains
The
them.
theory is super abstract, so it's important to continuously think about how it actually applies to doing AI tasks like controlling a robot or playing a game. So to that end, we are going to actually start this course with some games. The first game we'll consider is slot machines. This picks up where my Bayesian machine learning course left off. We did the same example there in terms of click-through rates, but in this course you'll see the concepts can be generalized to any kind of distribution. Slot machines, or the bandit problem, as it's known in reinforcement learning, will introduce us to an important concept called the explore-exploit dilemma. We'll discuss several techniques for making trade-offs between exploration and exploitation, including the epsilon greedy method, UCB1, and a Bayesian online machine learning technique. You'll recognize these from my previous course on Bayesian machine learning and A/B
He's
testing.
basically
since
selling
that is
all of
sort
his
a
other
subset
courses.
of what we did in
Yeah.
the first course. Reinforcement learning is all about trying to maximize a goal, or to use the terminology in this course, rewards. In A/B testing, the reward is a click on your advertisement or a conversion in your e-commerce store. So you see how it's a subset of reinforcement would also be
It's the way he
from
talks,
looking
the
at
way
my
he
name of
talks.
tic-tac-toe.
Yeah,
It's very
we
hard.
cannot.
But
The stuff he
come at it
presents
from the
is
perspective of
fairly
being a first-year computer science student. We'll ask ourselves the question,
like,
how would I
look at
coordinate game rules
reviews
that you need to
and-
follow with things? In the following sections, we'll introduce the central framework for solving reinforcement learning problems, known as the Markov Decision Process, or MDP. MDPs will allow us to formalize and abstract all the concepts we learned about in tic-tac-toe so that they can be applied to any game or scenario in the real world. Then we'll introduce 3 separate but related techniques for solving MDPs: dynamic programming, Monte Carlo methods, and temporal difference learning. All these 3 techniques look very similar, so I think what you'll find interesting is that the hard part is actually differentiating between the 3. In the last section, we'll do a little bit of a teaser and introduce what are known as approximation methods. The disadvantage of the previous 3 solutions to reinforcement learning is that they don't scale to large state spaces, or in other words, environments where you can find yourself in a large number of different states.
Make a decision.
The solution to this we give a function approximators. While we won't explicitly cover deep learning in this course provides all the techniques required to plug in your deep neural networks into your reinforcement learning agents. Without the theory from this course, doing something like deep reinforcement learning wouldn't make much sense.
Oh.
My original goal was only to do a deep
It's just a
reinforcement
teaser,
learning
he's
course,
saying.
but as I started to put together
This is
the
just a
directives,
teaser.
I realized there was so much.
He's not
Yeah, of
gonna
course it
teach
is.
you.
Yeah,
Yeah.
that's why it was free. It's just an
No,
advertisement
no,
for the
no.
rest of the
No,
course.
no, what is in this
No, you
course?
can go.
This
yeah.
course itself is a teaser into
No, no,
deep
no.
reinforcement
Escape,
learning.
hit escape,
Oh,
and then you can look at the course content that you have.
okay. Because he said deep learning won't make sense, so he's doing to do stuff.
He's very deep into theory.
Yeah, there was too much info. There was just too much info.
Yeah,
Okay,
that.
click that off. Okay,
And then go down,
okay.
and then there should be, oh, sorry, go up. Let's see where the course content is.
There should be a
Go down.
course content
There you go.
here.
That's all the stuff.
So what is reinforcement? And return of the multi-armed bandit, problem setup, explore, exploit, dilemma.
It should be.
I mean, these are all theory things, comparing different epsilons, optimistic initial values, UCB1, Bayesian Thompson sampling. This is all the theory.
So, are
You
we,
guys wanna?
yeah,
let's
are we
decide
meeting
on
next
this.
week? And if we are
Yeah,
we,
which one?
are we gonna do one of these things? And if so, who's gonna present or what videos are we gonna watch?
Yeah, so let's decide on that now before we go on.
Yeah.
Who has something that they can present on next week?
We want to do alternate between the 2 or something.
I mean, yeah,
That's
that's what
fine.
I
Oh, yeah.
suggested was to do.
Yeah,
do
alternate,
one.
yeah.
Okay.
But then if there's nobody who's ready to present, then we have to do a video. And so then
Where do we start?
we'll,
I have results, but I don't know whether it takes 2 hours.
well,
So you
then
can start.
That's fine.
Do a presentation, we
Okay.
start the video too. We can do 1 hour.
Because if you have material, we'll still have questions and stuff, so doesn't matter.
Ryan
I'm
is
sure
gonna wanna
we'll
talk
have-
about his
Yeah,
competition.
his competition too. I would have done the classifier. I would have done a
We
few
find
more
ways to
things.
fill the 2 hours.
Yeah.
So,
Second,
yeah, so next week,
Yeah.
Danilo will talk about his research. And we'll fill the rest of the time with Narayana's competition. And-
Yeah.
Sounds good, so.
And then after that, we'll do a video the week after.
Okay.
That sounds good. Look at the other one too.
See this one, you got to take this, and then he's saying
No,
you
no,
got to
that's a
take
different-
this one.
This is a different.
Oh, no, no, this guy has the same course, another course on there. When I clicked on this said,
Oh, I see.
see, when I went here, he said advanced AI deep reinforcement learning.
This
Is
is the next level.
the next level, because he's going to teach you the theory, and then you're going to learn this stuff.
Hold on. There should be another one.
Okay. So, I mean, deep reinforcement, you're going to have to put some hours into it to do this thing, because he's not, FastAI didn't cover the reinforcement learning. He's covered the GANs and stuff there, but not the reinforcement learning. Probably the DL2 he does next year will probably do that.
Who knows?
Hands-on stuff. There's not a lot of high ratings on these things.
Wait, if we do talks, what topics would be?
No, he said he was going to do something.
Amila's gonna give
No,
a
Amila's
talk next week.
Yeah.
The week after that is gonna be a video. And then we need to figure out what's gonna go off next, but it could be anything. Yeah, it's anything that anybody wants to present that they think is cool, that they think the rest of the people might think is cool too.
And
So if you wanna do one on reinforcement learning, like if you wanna dig into OpenAI Gym and get your feet wet, then just
Oh,
present
there you
it
go.
and,
Look at
yeah, I'd be interested in that.
Oh, okay.
This is another one that does reinforcement learning. This is the guys that do the A through Z courses. They're a lot easier to understand, like, to begin with. If you look at the content.
So
Which
there
one?
was a Papers We Love meetup that we went to.
Learn how
And the
to
guy
code.
basically presented on, I think it was somebody playing that
So
Moonlander
they
game.
tell you how to do that.
You remember the old Atari
Yeah.
Moonlander game? Is it called Moonlander?
Yeah.
I think it was
See,
called
he's doing some deep Q learning and all
Basically,
that
like,
stuff.
This one is actually pretty good. They
Yeah,
do
the
the
old
OpenAI
like
Gym.
Atari or game where you basically are trying to land the Moonlander on the moon.
Okay.
And so he taught.
And there is a
neural
lot more,
networks,
part
stuff
two
like that.
Doom and all that stuff.
That's all I do.
And it has a
But
decent
OpenAI Gym was
rating.
just full of like
Rating is
little
good.
environments.
I've heard about them, I've never actually.
Oh, that's learn how to build an AI. Is this?
I imagine there's tutorials you can just follow and then just show
Yeah.
us what you did.
Video, all the way to the right.
Oh, here? Okay. And there's 6,000 people have
Yeah, this
seen
one,
it.
I took this
I'm gonna take
one.
it.
Oh, you took this one? Pretty good?
Showing the
Yeah.
world.
It's a lot simpler.
Where it's.
But he has code and stuff and getting there. Okay.
OpenAI Gym.
Design courses.
Okay,
But in order to
cool.
get there, we need to start with a simulated.
Okay, I'll look at it. Oh, OpenAI Gym, okay.
Games are the simplest test environment for it. It can be applied to solve real.
Okay, cool. Yeah, no, this looks much more interesting than the other guy with the
Yeah.
monotonic voice.
They're
and-
very, these guys are better at teaching.
Oh, yeah. Yeah, it looked like he just had a thing, teleprompter, and he was reading like from the teleprompter is what it felt like.
Have you taken stuff from UW before?
Yeah, I take it, but most of my learning was Udemy.
I see, and so it's you guys probably work with them.
Yeah, you gotta look at the ratings, so because anybody can get on there, you have to be the ones that have the best reviews. If you do that, then you will find the courses.
Okay.
Because basically